Okay, so we are going to perform the tensile test in the flat specimen. So the first thing, this is a sub size, so we have 2-inch length. The gauge length is going to be 2-inch. We need to do some marks, and we need to first measure the initial width and initial thickness of the sample, and obviously mark the 2-inch mark for the elongation. Okay. So we are going to use some calipers. So first we are going to just using millimeters for now. Just make sure that they are in 0.
Width.
That's the thickness.
13, 14.
13, 14. 13, 14, and
thickness is 4.94.
yes, 4.94. Okay. Now we are going to have some distance between 2-inch mark, which is approximately 50 millimeters. So we can use 50 millimeters of 2-inch, and basically it needs to be centered in the small section area. Okay, so approximately there. So basically we need to mark them. We can use a Sharpie, but they are gonna probably erase. So instead of that, we are gonna use the
Scripter.
engraver. That's what it's called, engraver. Okay. So approximately we are gonna move here 2-inch and make sure that it's centered. Approximately there. So I'm gonna start. Don't make it too sharp because it could affect the test, right? So it should be just superficial, but because I just make it manually, I'm gonna measure between them exactly what is the distance, because it's not 2-inch because I move manually with my hand. So I just come here and measure, and it's gonna be 50.95. So that's our length, 50.95. Okay, so take care of that. Now the next thing is configure our setup in the machine. So we have our sample. Okay, we have our 2 match, and we are gonna mount it here, and we need to raise. So this side is fixed by this crossbar, and this side is gonna be moving. So this is moving down or up. So we can raise this guy up and down. If we want to adjust the crossbar, the top one, we can do it. Just simply use following the instructions here. So right now it's locked, so it means that this is fixed. The crossbar is fixed. We can unlock, okay, example there, and now I can move up and down the crossbar and adjust my height. So for example here I'm gonna move down, you see how it's moving down, or I can move up.
It's a pneumatic system.
Hydraulic. Yeah. So I can just put it depending on what I want in a particular position. I'm just gonna leave it there. But make sure that before I start the test, I need to lock it. In other ways, it's not gonna run it. So it needs to be locked, okay? Because this needs to be locked, this machine. Now, when I'm happy with my position, I can move this piston up and down. So for moving that, I can come here and notice that the interlock, it's on. It's because I unlock the crossbar. You know, and you can see here the interlock is on, but I can reset that. Now, if you click here in manual commands, so this is this button here, the 4th button in these station controls, it's gonna open this manual commands window, and I can control the displacement activating here the enable manual command. So when I activate it, I'm able to move the piston there. So there are different ways to measure. There is a way that is this is fast. So I click in the roller here, and as you notice, the piston is moving up. Okay, and as you notice, it's a medium velocity. The other way to move it is clicking here directly in the arrow. It's still moving, but it's really slow, so it's hard to see how it's moving. So this is for fine tuning. Okay, for coarse moving or coarse tuning, I just move it, clicking in the ruler, so it's moving up. Okay, so I can place it in a position that I consider it's good enough. Yeah, just to the length of my sound. Okay. Now I can just come and kind of see. So it's still far from that, so you can just click, click the ruler. Another, so click the ruler. Click. And when you are moving, I prefer don't be my fingers not close, because if you do a mistake and move it fast, it's gonna, injure my fingers. So go ahead, more. Stop there. So I'm gonna position my first sample here, and there is two valves here, one for the top grip and one for the lower grip. Okay, now right now they are all the way to the left. I need to move all the way to the right to apply the pressure, and I can regulate the pressure with this knob. The pressure usually what we put for a steel is around 20 megapascals. That's the pressure that we put there, 20. Okay, when I activate it, so we'll see how it goes. So I'm just gonna put it, and the other thing that I need to do is put it as straight as possible. That's something that we can verify with a laser in a minute. Okay, so I'm gonna position, and I'm gonna move all the way to the right, and you see that the grip close. Okay, now if you notice, the pressure is raising, but it's kind of low pressure, so I'm gonna increase a little bit. We shouldn't move this one too much. Should be fixed. We just did some tests the other day, so that's what we decrease it. So if you don't put too much enough pressure when you are testing, it's gonna slide. So we need to be really well clamped. So around 20.
Lock, right?
Yeah, this lock right now. Okay.
Oh, after 20 it will not increase.
Right. I mean, we can keep moving here. So we can unlock going to the other side, or lock to this side. Okay. Now this is too low, so we need to go up a little bit more up. So always that you are moving the machine, you need to keep an eye that you don't crash anything. Because if you are moving and you are crashing the machine is gonna keep going.
Yeah, got it.
And it's gonna break the machine is gonna break some component, because you could have like a lot of pressure there.
This is so.
No, keep going. So usually we do symmetry,
Yeah.
If we see like we just hanging from the shoulder, so we need to be much higher there. Let's try there. So now I'm gonna go with the lower grip. So again, it's in the left side. It should be the same power. So I just go to the center and all the way to the left. So it rotates.
Grip must be after the edge, right?
Sorry?
After the corner, we will grip the sample. Yeah, this.
Yeah, a little bit. So we can adjust that. But you notice it's oriented in this way. So we have our two marks there. So what I'm gonna do is I'm gonna open a little bit here. And I'm gonna open this guy. And I can just position at the center. So the idea is to be symmetric at least, okay?
Yeah, between these two.
Now, we have this laser extensometer, okay? We are gonna use this laser extensometer for checking the elongation, but also we can use it for verifying the height, how straight is the sample. So, we have a power, a cord connected here, and to transmit the signal, we have this port here, the analog output. So it's going to the analog output there. Okay, now we can start our system. The laser is disabled, so we can enable it. Now the laser is on. So you'll see the laser there. Okay. So since that the machine is too high, but we can move it a little bit this, but the piston is going as well high. So let's see if we can do it this. You can probably unlock here, going up. No, it's not bad. So if you notice, the laser is pointing kind of the straight line there, and it seems that I didn't do bad. So it seems that it's straight. Sometimes if I'm exaggerating, but the sample could be completely inclined.
But it's not in the center, right?
It doesn't matter.
Okay.
The important part is that it's straight.
Okay.
Okay, it's straight. You can put it closer to the center, but straight. That's the important part. That's what I'm checking right now. But it seems that it's straight, so I'm happy with that. So now I'm just gonna make sure that I'm aligned there. So this extensometer works with a reflective tape. Right now it's invalid because it doesn't have any reflective tape. So usually we just keep the reflective tape here in the machine. We have an old one. It's brand new. So what we do is we just manually have like a decent piece, and this is adhesive, okay? Sometimes you need to fight with the adhesive paper. You get it there? So the idea is it's adhesive, so I'm gonna place in one of the marks that we did, okay? The scratches that we did, so the top one. And make sure that it's well connected there. Now, I'm gonna take a second one.
The two mark we have done.
Yeah, but we need to measure approximately 50. Now, this signal should be transmitted here to the machine and this auxiliary input too. So the same data that we are measuring in this screen should be measured here. See what happens there. So right now I'm putting there 43, 40, and what is the number here? 46. So it should be the same, right? So it's a good transmission. So you always check. But what I'm going to do is I'm going to place this mark closer to our scratch, but approximately leaving 50 millimeters, which is our gap. So I'm going to place this one, just looking at the screen. What is that? 49.
49.7.
49, 50 is fine there. Okay, so 49.6. 49.6. So we are fine. So that's the distance between these two marks. Okay. So the lower grip is still off. Okay, it's still open. I haven't closed completely yet. And what is the reason why? Because we need to normalize the force. Okay, so we haven't moved this one. You know, we are not going to move this one anymore. So the manual command can be disable just for safety reasons. Now the next step is just coming here to station controls again, and the first icon is going to be auto offset. Okay, if I click that, it's going to show me the different instruments, including displacement, force. So right now it's measuring 1 kilonewton of force. This 1 kilonewton is the weight of the system, whatever is there. Okay, so I need to make this 0 because for my material I don't have any load right now. So it should be showing 0 force here. So I need to place this one in 0. So for
channel 1
offset the force, I just go to force channel 1 and click this in offset. So I put the force in 0. If I want to clean the offset, I just clear all of the offsets here. So now it's measuring the total force that it's measuring. By the way, the load cell is located here. Okay, so this force is basically all of the weight of this component plus the sample. Okay, because it's hanging on that. So I need to put it on 0 again. So I'm going to come in here to the offsets and clicking in 0. I can also 0 the position, but I don't care. But I don't care that because I'm going to follow the elongation from the laser. Okay. Okay. So we are set there. Now we can close it. Okay. So we can close that all the way to the left, and you're going to notice that the machine applies some force, but that's okay. That's actual force in the machine. Okay. I recommend always to preload. So right now you see it's minus 0.3. So actually the sample is get compressed by the closing the grips. So if I want to put like a force, a pre-compression or pre-tension, I manually can do it. So I can come here to enable and do that again. Do it, but just with the arrows, the final tool. So if I go on compression, I go this way. If I want tension, I go this way. So for example, if I click one time here, you're going to notice that this value go to
Tensile mode.
0.6 kilonewtons. If I go to the other side, it go down to negative 0.3.
Compression.
I wanna put preload tension.
Yeah.
Okay,
Then
so
positive.
I wanna just put this way, and I pretension 0.6 approximately kilonewtons. If you have a tiny sample, that's a lot, but for this big sample, it's fine. It's, you know, it's a small force there, 0.6 kilonewtons. So I can disable now. So it's preload. Okay, so everything is almost ready to go.